Okay, perfect. Here we go. So today, our first session is going to be about, as we work with text in this course, today it's going to be about how can we manipulate the text. So when we analyze data, it's like this will be mostly used for data cleaning, I guess. So you could think, for example, okay, we have a data set from Twitter, and we want to, for example, remove all hashtags in these tweets because we don't want to have like we're not interested in them, for instance, or we want to remove all the at links on Twitter. So that would be one use case for string manipulation in our case. Or we want to remove all punctuation because we don't need it, or there is something wrong with, say, a bunch of emojis or some encoding problems, something like that. Like there are many reasons why you would want to actually clean text, and you would want that in a way that scales well. So yeah, why I'm mentioning that it should scale well. Well, of course, when for cleaning the data, you can of course export the data, say, into a CSV file, open it in Excel, and then you can make all your changes by hand. This works fine, but it's also kind of tiring. Like it works fine for like maybe the first 100 occurrences of a certain thing that you want to remove, but thereafter it becomes pretty tedious. And therefore we need, or we want, some R functions that we can use to actually manipulate strings or text in R. So just a quick reminder or a revision. I mean, all of you know that if you have ever worked with R, which you all have. So a string is basically an element of a character vector, and a character vector is the most basic and powerful probably class in R, or type of vector in R, because it can contain literally everything, as long as it's wrapped by 2 quotation marks. So here, for example, a string would be hi, how are you doing? This is, on the one hand, it's a character vector of length 1. On the other hand, it's like the single element in the character vector. And then a vector of strings would be here, like a vector of length 3 with hi, how are you doing is the first string, then I'm doing well, how about you would be the second string, and here's the third string. And this is, again, like that's a vector of strings, basically. It's a character vector that contains 3 different strings. And as you might have noticed, you can either wrap, or as you might know, here I'm using like a single quotation mark in the string for the writing I'm instead of I am, and this is fine as long as I wrap the text into like the string in 2 quotation marks. But I can also do it differently, and if I want to use double quotation marks in a string, I can wrap it in single quotation marks. So both works. What doesn't work is wrapping it in single quotation marks and then using single quotation marks inside the string, because of course R would think, oh, okay, this element ends here. Yeah, that's just for completeness sake, if you will. So what if we want to manipulate these strings? So for example, here, the what's up, it's all lowercase. I want it to be title case or uppercase. Well, do I have functions for that? And there is a package in R that has a multitude of functions, yeah, 49 in total, which doesn't really matter, that can be used to achieve a lot of things that are related to the manipulation of character vectors. What's that? Yeah, here's an and. And so you can manipulate character vectors, and you can also find and match patterns in them using regexes. So in the following, you will first learn these basic functions, how you can manipulate character vectors, And then in the second part of our session today, we will be talking about finding and matching patterns using those regular expressions. Exactly. And there are, in theory, a couple of functions in base R as well that you could use to do that. But the big advantage of the Stringer library, as with all tidyverse packages basically, is that it's super consistent. And the makers of Stringer describe Stringer as a consistent, simple, and easy to use set of wrappers around the fantastic Stringy package. So Stringy was basically the precursor of the Stringer package. Like the Stringy package is written in C, and it's like not as consistent as the Stringer package, but it can basically do the same things. But the Stringer package uses Stringy, but gives it like a better or a different syntax, if you will, which is like more consistent, etc. And so what's the good things about Stringer? So the first good thing is that all function and argument names and positions are consistent. So what do they mean by that? So the function names are insofar consistent as they all start with an str. So if you are not sure which stringy function to use, you can just type str underscore and then you will find it. So for instance, here I need to load it first. Sorry, library tidyverse. So you only need to load tidyverse for Stringer because it's part of the core tidyverse. And then if I want to find the Stringer function, I just type str, and then here we find all the different Stringer functions. Yeah, and you don't know what to use them for yet, but that will hopefully become clear later. Yeah, so that's one advantage. The other advantage is that, let's take here str count. So what you see here is that the first argument of the Stringer function is always the string. So here with str count, first argument is the string. Second one for str detect, first argument is the string, etc. Therefore, like you might know how the pipe works. Like the pipe always replaces the first argument in a function call with the output of the function that came before in the pipeline. And therefore, all the tidyverse, and because all the tidyverse functions take the object that it performs actions on as the first argument, we can pipe them with ease. And this is the same for the Stringy package, as Stringer package. With the base R functions, on the other hand, the object that is performed an operation on comes as the last argument, for instance, which makes it super tedious to work with them in an in a pipeline, if you will. Yeah, the next thing is that all functions deal with NA values and zero length vectors in the same way. So your code becomes like it fails in a predictable manner. And last but not least, which is what I referred to before, which is related to the position. And the output from one function is easy to feed into the input of another through pipes. So those are basically the upsides of the Stringer package. And we will now go into how we can use the Stringer package for really basic manipulations of strings. And with basic, I mean we change the case, we determine the length, etc. So here again, to load the Stringer package, we only have to load the tidyverse package, but of course we can also just load the Stringer package in an isolated manner. So here, library Stringer calls the Stringer package. So let's take as a first one, different cases. So our vector of strings here is in like the proper case at the moment, like it's the first word in the sentence is uppercase, and or like the first letter of the first word in the sentence is uppercase, and here how about you is an abbreviation is all uppercase as well. So this is correct. But what if we wanted all lowercase to, for example, unify the text? Like when you have a data set of a lot of tweets, for instance, people follow different styles online when they want to write tweets, even though they might use the same words and want to say the same thing. Like some are too lazy to use the proper casing, for instance, or some others are really angry and want to use uppercase only, etc. So what if we want to unify that? We can use a bunch of stringer functions for that. To make it all lowercase, we use str to lower. To make it all uppercase, we use str to upper. If we want to have title case, which is basically that every word has like the first word, the first letter of the word uppercase, we use str to title. And if we want sentence case, which is what we have here, more or less, we use str to sentence. So of course, these functions are not perfect. Like they're stupid functions. They follow like really basic patterns. So here, for instance, sentence case does not recognize how about you is an abbreviation, and it makes it lowercase, because sentence case usually always only makes the first letter of the sentence uppercase. Title case, however, is usually used in such a way that shorter words, or words that are not, how do I put that? Like title case has different conventions. Like the New York Times, for instance, has a quite authority, like is quite an authority when it comes to the conventions of title case, and they would probably not put the first letter of vowel as an uppercase, or better said, the first letter of the for in uppercase in the title case. But the stupid str to title function does that, of course. So those are no silver bullets, but they're quite helpful. So this is what the outcome of the different casing functions look like. A next use case would be the determination of a string's length. So we want to know how long the string is, which is how many characters it contains. And for this, we just use str length, vector of strings, and then it will tell us, okay, the first string has 22 characters, the second one has 20, and the third one has 26. Yeah, that's it. That's we don't need no more. What we can use that for is, for example, and we will see that later, if we use it as an if-else function, for an if-else function, for instance, where we can say, okay, str length needs to be larger than 20 or something like that. Yeah, the next thing is if we want to extract particular characters based on position in the string. Like we will hear more on how we can extract particular patterns or words from a string using regular expressions, like, which is a more advanced way of extracting things from a string. But here we just extract characters based on their position. And we can do that using str sub. And it takes the function takes the following arguments. The first function is the string itself. So in our case, it's the vector of strings. Then the start, which is what is the first thing to be extracted, and the end, which is like what is the last thing to be extracted, and everything in between is extracted as well. And then this looks like this. So here again, every singular character, like also spaces are considered characters, are extracted here. And what if we want to do it from like in the first case, we do it from left to right, like as we read a sentence in the English language, or in the German language as well. But sometimes we also want to do it the other way around. We want to start, like we want to count from the end of the string. And for this, we can use -5, or we just use minus. And in this case, the first, like the start needs to be smaller than the end, as in the other case as well. So here, like if we do this, we get the fifth to last character until the very last character. So this looks like this. we can also use str sub to replace things. So in this case, for instance, we would want to replace the last character in a string by a full stop. And for this, we can just do the following. So here we specify, or we use basically extract the position of like we look at what is the last, what comes on the last position of our strings. And this is achieved by that. Like if we just want one character, we omit the end argument, we just use the start argument. And if we want the last character, we use -1. And then we assign to this last position in the string, we assign the full stop or the dot, if you will. And then it looks like this. So here we used to have a quotation mark, a question mark after "Hi, how are you doing?" And now we have a full stop. So this is how str sub can also be used to replace string or to replace characters in strings based on functions, based on position. Sorry. But beware that in everyday use you would probably go with str replace and regular expression, which is like more advanced and more reliable, and we will hear more about that later. This is just to show you what you could do. The next example for what you can do with stringer is concatenating strings, like gluing them together, basically. And in R, if we want to put together or glue together or concatenate different elements of vectors or vectors into a single vector, we can use the C function. C stands for concatenate here. If we want to put together different strings into one string, or basically into one string, we can use the stringer analog to the C function, the strc function. And what this looks like is the following. So here I want to write some birthday invitations. The names you can see here are more Swedish names, because like this script was originally part of a course I taught at the Stockholm School of Economics, and I wanted to feel them more at home. But here I have 4 different names like 4 different persons who I want to invite to my birthday. And I do that using R. There's actually a function which allows you to send emails from R, for instance, if you want to send some spam mails or something like that. But here for this, I want to write some nerdy birthday invitations, and I'm too lazy to replace the name every time from a new. So I just combine these 2 vectors. So what I want is a vector that basically invites the respective person to my birthday. And here I define the different names. It's Inger, Petre, Kalle, and Ingrid. And here's my text. So it's "Hi, I hope you're doing well. As per this letter, I invite you to my birthday party." And then here after the "hi," I want to have the name. And here, this is like basic C, like the C function syntax as well. Like for the first thing in the string will become the "hi," then the respective name. So this is vectorized. So it will, in the first element, we'll put in the Inger, in the second one, the Peter, then the Kalle, and then the Ingrid. And then I will have the "I hope you're doing well, as per that I invite you to my birthday party." And this will repeat it like all over again. Sorry for that. So this is what the outcome looks like. So here I have "hi," then it just pastes the first element of the vector, then here the second, the third, and the last. And that's it. But of course, this looks ugly, because the problem is that it just glues them together. Like it doesn't put in like a separator. However, I can specify a separator using the sep argument. So here I would do "hi," then a comma and a space, the name, a comma, and a space. I hope you're doing well. As per this letter, I invite you to my birthday party. And this I do that by specifying the SEP argument. And then it looks like this. Hi, then the SEP argument, second element, which is Inger in this case, then again the separator, and then the rest. Sometimes you also want to collapse the strings that are contained in there in a vector together into one single string using the collapse argument. So for example, if my mother asks me, hey, Felix, who are you inviting to your birthday? And I will tell her, hey, it's SDRC names collapse, comma, and then I will give her this list. So what the collapse argument does in this case, it just takes a bunch of vectors or elements of vectors and collapses them into one string. And here, it's not like it's a collapse true, but you just specify how you separate the different elements of the vector or the different vectors, and then it becomes one string. So here, if I remove the comma, for instance, it will just be like this. So the comma will be removed. And note that it will not be added, just added to the string, but it's only between the different elements. There's another function for achieving that, which is the str flatten function, which is used to basically flatten down the different elements into one string, but it does the same. They're perfectly analogous. Okay, then you can also repeat or duplicate strings using the duplicate function. And this is basically the expression of the base R wrap function, but for strings. And the function basically takes two arguments, which is the string to be duplicated and how often you want to duplicate it. And yeah, so this looks like this. So if I want to write my name 2 times, I would just do Felix and then 2, and then it's Felix. And if I wanted, like, if I give it a vector of length 1 and then a vector of length 3, I will receive a vector of length 3. So here in the first one, it's duplicated. It's repeated once, so it's Felix. And in the second one, it's Felix, and then Felix. And the same can be done vice versa. So here, each name is just doubled, basically. And then if I use different vectors of like different length or vectors of the same length, then the first one, Inger, will be written once, the second one twice, the third one 3 times, and the fourth one 4 times. Looks like this. What doesn't work is that if they're of different length, like they should be multiple of the shorter object length. But again, what it does then, it gives a warning, but it recycles the shorter vector. So here, Inger is repeated once, then Peter 2 times, Kalle 3 times, Ingrid 4 times, and then it starts with Inger all over again. And Inger is then repeated 5 times. Another use case is removing unnecessary white spaces, because like text that you acquire from online data, or if you scan books or something like that, there's a lot of things to go wrong when, for example, the scanner wrongly recognizes white space. We want to remove them, and there's a bunch of functions which make it very easy. So here in the example vector, we have in the first element, the unnecessary white space is on the left. In the second one, it's on the right. Then we have it on both sides, but not in between words. And then in the last one, we have it everywhere. Like we have unnecessary white space on the left. We have it in between the 2 words. And then we also have it on the right. And there are basically 2 functions if we want to remove the rights. Like the first one is str trim, and the other one is str squish. str_trim basically trims away white space from the sides. We can specify the sides. So here, the first one would be if we want to remove white space from the left, this works with str_trim, and then the argument side left. So here on the left doesn't have any unnecessary white space on there anymore. But the white space on the right here is still there. And we see better in the on both sides thing where it's removed on the left, but it still exists on the right. And then with literally everywhere, we see it that it's removed from the left, but it still exists in the middle, and it also still exists on the right. And right is basically the equivalent to that, but with white space on the left being untouched. And then the default option is both. So this would trim away white space on the left, it would trim away white space on the right, and on both sides, yeah, naturally. And then, but here with the literally everywhere, the white space in the middle would still remain in there. And since it's the default option, we can just, if we use str_trim and then just the string, this is exactly what will happen. All right, but str_trim here could not fix the last one where we want to have the unnecessary white space removed in the middle or in between words. And this can be achieved using str_squish. And the rule in str_squish is that if white space is on the left of a string, it will be removed entirely. On the right of the string will be removed entirely. And if it's in between different words or numbers or whatever, it will be reduced to 1. So here, str_squish removes the white space on the left, it removes the white space on the right, as we see here, and then it condenses the white spaces that are in between words to only 1. And yeah, so this have been the basic functions of the stringer package. Now we can go to regular expressions, but I will take a 5-minute break. I will stop the recording now, or pause it. I will stop it, and then you can ask questions for 1 minute, and then I will go to the bathroom.